I am Vanel. I am a master's student at Kennesaw State University, and today I will be presenting about developing and assessing unsupervised anomaly detection methods using HPCC systems. So I will start by a quick poll question. So have you ever had to analyze a log file to get insight about an anomaly or a bug? So you can answer either yes or no, and the answers of the poll question will be given at the end of the presentation. So I will start by the project description. So as mentioned earlier, my project as a summer intern was to develop and assess unsupervised anomaly detection methods. So anomaly detection can spread over many domains. So we have intrusion detection, fraud detection with credit cards, and we have log-based anomaly detection. This one is a rare anomaly detection system, but it's the one I've chosen because it is tightly related to my thesis. So having chosen that, our specific project ended up being developed and assessed unsupervised anomaly detection methods for detecting anomalies in a system through log file analysis. So throughout this talk, we're going to discuss about a brief background on log-based anomaly detection. Then I'm going to describe the data set used for this experiment. Then define our target anomalies, and then the methodology used to find those anomalies, and we will conclude. So about log-based anomaly detection. So this picture shows the four main steps which most of the works on log-based anomaly detection have been using. So this picture was taken from the paper shown on the PowerPoint below, experience report from Shinli He and al. So in this picture, the first step is log collection, which is basically getting the logs from any device or from a system. So that's the first step. Then the second step is log parsing, because most of the time logs are unstructured. So this second step just aims at giving them some structure to know what's the date, what's the IP address, basically structuring the logs. Then the third step is feature extraction. At this step we get exactly what we need for anomaly detection. From this step we get our vectors. And the final step is anomaly detection. So most of the work now with the advent of machine learning deals with anomaly detection using machine learning. So this is what of the works do in terms of log-based anomaly detection. So they only differ in the content of each of those steps. So having said that, I'm going to now describe the data set we use for our experiment. So initially we wanted to use HPCC systems log files. However, I was working remotely, so it was a bit insecure to send the logs remotely. So we end up choosing a freely available log data set in the name of NASA HTTP web server log data set. And it is basically the records of requests made on NASA HTTP web server for the month of July 1995. And this picture shows a sample of the data set. So these are the first 10 records. And we have we have the IP address, we have the date, we have the request made, we have the reply code, and we also have the number of bytes in the reply. So for the whole data set, we had about 2 million records, basically. And when you are given such amount of records to analyze manually to detect some failures or some unusual activity, so this is usually the head you're going to do because you don't know where to start. So we define our target anomalies for this data set. So our target were twofold. So we had first user anomaly and then workflow anomaly. So user anomaly detects users having a significantly different behavior from the majority of users. So an example would be an extremely active user. And then workflow anomaly detects abnormal periods of activity. An example would be a period of low activity, maybe because some servers were down. So these were our target anomalies. So what was our methodology to find those anomalies? So at the heart of our methodology was K-means algorithm. And for this, we used the HPCC system's K-means bundle. And we had three main steps in our approach. The first one was feature extraction. Then the second one was to use K-means clustering. And then the final one was to use the results of K-means clustering to detect our anomalies. Now I'm going to dive into each of the steps for each of our anomalies. So let's start with user anomaly. So our features for user anomaly was, we had 7 features for user anomaly. So the first one was the average request submitted by each user in the first 8 hours. Then the second one was the average request submitted by each user in the next 8 hours. And then the third one in the last 8 hours. Then the fourth feature was the number of active days, which is basically the number of days the user has been active over the month. And then the fifth one was the average unique daily request, which is basically the average number of requests submitted by the user daily, not considering repetition. And then the before last one was the average daily request, but now not considering repetition instead. So, and now the last one was the average daily bytes in reply, which is basically the average size in reply of daily requests for each user. So those were our 7 features for detecting users' anomalies or to differentiate each user. So having our features, now we move to K-means clustering. So we have to cluster each user. And this is a summary of the K-means clustering process. So the main step in K-means clustering was to decide the number of clusters. And to decide the number of clusters, we used 2 main things. The first one is shown on the left. We had a visualization of our 3 main features in a 3D graph. And this is shown on the left. And on the right, we have a plot, which we call the elbow plot, which shows on the y-axis the number of clusters, and on the x-axis instead the number of clusters, and on the y-axis is the error. So using visualizations, we end up deciding on choosing just 1 cluster for this particular anomaly. And the table below shows the final position of our centroid. So having the final position of our centroid, now we have to use this to detect potential abnormal users. And to detect potential abnormal users, we basically try to find the distances of all the data points or all the users to our centroid. And we did this and got the following graph. On the y-axis, we have each user ID. On the x-axis, instead, we have the user's IDs. And on the y-axis, we have the distance to the centroid. So now we have the distance of each user to the centroid. And using this graph, we set a threshold above which we will consider a user being abnormal. So having set this threshold and applied our filter, we ended up having 20 potential abnormal users shown in the table in the slide. And then after analyzing our results, we ended up concluding that we were having 2 kinds of abnormal users. So on this table, we have in the center, we have the centroid, and then on the left, on the right, we have each type of abnormal users. So let's start by the left one. So the left one shows, if we go on the row concerning the number of active days, we see that this abnormal user has been active the whole month, which is 28 days. While the centroid tells us that most of the users have been active between 1 and 2 days. So, and also comparing also the number of requests submitted by this user, we ended up concluding that this user represents the very active users over the month. And it would be worthwhile investigating why they have been so active and every day. Now we have our second potential abnormal user on the right. which shows a pretty normal number of active days, in this case 1. But he has a really high number of submitted requests in the second 8 hours of the day, and who knows why. So this is labeled as a very active user on a particular day within a specific period of time. So this was our result for user anomaly detection. And before moving to workflow anomaly, we're going to get our second poll question for this talk. So on a scale of from 1 to 5, 1 being easy and 5 being hard, how difficult do you think it is to determine the cause of a failure from analyzing a log file? So you have to answer between 1 and 5, and the results of the poll question will be given again at the end of the presentation. So now let's move on to workflow anomaly, and which aims at detecting abnormal periods of activity. So as for the first anomaly, we had to define our features. So here the first step to define our features was to set the period of activity. And for this one, we decided on 1 hour. And this is a parameter. It can vary depending on the system and depending on your needs or depending on the organization. So we decided to choose 1 hour as period of activity. And the second step here was to divide the data set into windows depending on the period of activity chosen. So we divided the data set into hourly windows. Then the final step to get our features was to count the number of occurrences of each request per window. But so on the left, we have the window IDs, and then we have the count of each request in the table. But at this step, we encountered an issue, which is mainly a dimensionality issue, because we were having about 22,432 unique requests, which is making our features to have a dimension of about 20,000. So that was really huge, and we had to find a way to reduce the dimension. So thankfully, most of the work people have thought about it, and most of the researchers have decided to switch from counting requests to counting events. And events are basically log templates. So to understand this, we can treat get image, get file, and get image. So normally, each of those requests will be counted individually. But now, instead of counting them individually, we get instead their template, which is get star, and now we count them as a single event. So this is the basic idea in dimensionality reduction. And many researchers have developed systems to move from request to events. And among the many works which have been done on the domain, they have chosen Spell, which is a streaming parser for system events log developed by Mindu and Fei-Fei Li. And it is based on longest common subsequence. We chose this approach simply because it was fast and accurate for our needs. So having chosen Spell and applied it on our data set, we ended up moving from 22,432 unique requests to 3 events, and which were get star, post star, and head star. And the table below shows a sample of our features extracted. So we have the window ID and the count of occurrence of each of the events now instead of each of the requests. So having now our features, we again move to clustering as before for the first anomaly. And we again have on the left, we have the visualization of our features, and on the right, we have the elbow plot. And this time, having these two, we decided to go with 2 clusters this time. And the table below shows the final position of our 2 centroids. And again, to detect each of our anomalies, we plotted the graph of the distance between each member of each cluster to its respective centroid. and we got the following graph. So this is the graph showing the distance between the data points in the first centroid in the first cluster to the first centroid. And here we decided again on a threshold beyond which the period would be considered abnormal. So this is for the first cluster, and this is for the second cluster. And after applying now our different thresholds, and we got the following potential, we got 11 potential abnormal windows of activity. So we have two tables. On the left, this is the result gotten from cluster 1, and on the right we have the result we got from cluster 2. And after analyzing and comparing that to our clusters, we were able to conclude that on the left we were able to detect the most active windows, and on the right we were able to detect the least active windows. So at the end of our presentation, so we were able to develop and assess two unsupervised anomaly detection methods using k-means clustering. So from a web server log, we detected potential abnormal users as well as potential abnormal periods of activity. So those information are more useful for a system administrator instead of having to read each line of log without knowing where to start and where to stop. So the source code of this experiment, of this project, can be found on GitHub in the link shown on the PowerPoint, as well in the attachment. As future work, we intended to think about finding the root cause of the detected anomalies, because it's good also to say, okay, we found these potential abnormal users, but it will also be more helpful to know why is that user considered a potential abnormal user. And then another future work is to develop an online anomaly detection system, because this one works in batch mode with a monthly record, and it will be more helpful to be able to analyze the logs in real time. And the final way to improve on this work will be to experiment on other types of log files. So thank you for listening to this presentation, and I'll be listening to any question you may have.
Thank you, Vinal. I think this is such an interesting topic given the need for companies today to detect intrusion and fraud. So while you go and review the questions that have come in from the audience, I will share the results of your first poll question. And you had asked, have you ever had to analyze a log file to get insight about an anomaly or bug? And the results show that 100% of the people who took this poll said yes, that they did. So it sounds like we have the right audience here listening in to the talk today. So if you are ready, let's move on to your Q&A. So the first question is, what do you think would be the solution to make log analysis easier?
All right. So there are many problems today in log analysis, and there is a root cause which is related to logging systems, because there is no standard in logging, and many engineers they design their log system the way they like, and sometimes they make errors. So a way to make improvements will be to standardize logging, and also another way to improve on making log analysis easier will be to reduce the workflow as well. So those are the main I would say the main things I think about giving a solution to making log analysis easier.
Okay. And one other question that came in, what are the main challenges of log-based anomaly detection that you see?
Okay, so the biggest challenge in log-based anomaly detection is, as mentioned in the presentation, the company could not send me the logs over. So companies are hiding their internal logs, and this makes improving on log analysis a bit complex. So that's one challenge because of security. So another challenge is the explosion of big data, and security analysts can't understand all the logs, all the works, all the logs. They can't really understand everything, and that makes it more complex for them. So those are the main issues for me and the main challenges in log-based anomaly detection.
Well, thank you for providing that insight. So before we wrap up with Vinal, let's go over the results of your second poll question, which was, and I like these questions, on a scale from 1 to 5, with 1 being easy to 5 as hard, how difficult do you think it is to determine the cause of a failure from analyzing a log file? And from the results, 60% of the listeners said they rated it a 3, so I would say average, challenging, and 40% rated it almost a 4, so almost as hard. So it definitely looks like what you're sharing here will help our users. So thank you again, Vinal, for your insight on this topic and for your contribution of the anomaly methods that you shared with us today.
All right. Thank you, Trish.
Thank you. All right. So at this time, I would like to turn things over to our next speaker, Farah Alshanik from Clemson University, and she'll be presenting her work